There's only one merchant outside today.
Spell it wrong.
Huh?
Rog.
Oh. Rog. All right. Now it is right. Make sure that it is recording. Yep. And here is exam 2. The other student is still, working in the lab, but since, the recording is not live casted, so he cannot really see the solution that we are talking about right now. Unless, this room is bugged. All right, let's go ahead and take a look at the questions, and, I'll give you guys the solutions. The first one, with all of these, we want to save the file first. I don't know exactly why, but if you open the file inside the browser and then you save as, it crashes, OpenOffice with some of the files. I think STI and Civic are the two, that will crash the browser. The other ones do not, so that's kind of mysterious. All right, let's go ahead and take a look. How many people actually brought along your own portable installation of OpenOffice? Did it help? I mean,
Mine crashed.
No, crashed.
Crashed? Even if you do it this way?
Yeah.
Yeah. Mine crashed when I was trying to do strike-through.
I was like halfway
Crashed,
through.
locked everything out.
I was like halfway through.
Control 1 crashes everything when you try to put it in.
Control
Did you guys
1?
do the save link?
Mine
What?
worked.
Did you guys do the save link?
I did a right-click, save as.
Okay, 'cause that's-
I didn't know what to do with that other window that
Yeah.
came up.
That was the
It
only
goes
thing that
nothing.
Save link too, yeah.
Just gave me the name.
And then I saved it all to the desktop, and then I went into my open office and went open file and got it out, and it still crashed.
I had no issues whatsoever. I didn't either.
So
The
it's
ones who did, you get some credit for.
I think I won 5 bonus points.
I was going to say 10, actually.
So where is this supposedly saving it right now?
me.
Yeah, when that window comes up, it says download.
I
It tells
picked
you the file name, but it's
I picked exactly where I want to save it, because when I click save link as,
But the computers in the computer lab will save it to your temp folder.
it will save it to the download folder. It's my documents and my documents download or downloads. So it always saves it to that location.
Why don't they have moving profiles set up on the there so that your profile will stay the same?
Well, I have a better question. Why don't they use Linux? Really, really. I mean, using Linux, can save a lot of trouble because, we can network mount a drive and, and be done with it. I mean, I have been using Linux, for this class, since the beginning.
Let's do it.
And
Let's create an uprising.
it's already
Let's go
happening.
in there and reformat everything.
It's already happening. Microsoft just has not realized that yet. Android, yep. Well, they're suing. Microsoft is suing. All kinds of people. Google is getting sued. Left and right. For different reasons. So that's a good gauge. That basically tells people that Google is being quite successful at this point. If you're not successful, you don't get sued. What was the last time that somebody sued, say, WinZip? What company again? WinZip? Well, they used to make an unzip program, for Windows, and nobody really cared about that program anymore. Yeah, okay. Because Windows has a built-in ability to deal with zip files, and for everything else, there's 7-zip, which is an open source program that is free. So nobody bothers with WinZip anymore. But I made a mistake of actually using WinZip like a long time ago, and they kept my email address, and they keep sending me email messages of, oh, guess what? You can use WinZip for da. Yeah, but I have 20 other programs to do the same thing, and they all do a better job than WinZip. But the company is still around, which is kind of amazing to me, that they can just.
Nobody sues Kmart. Nobody sues Kmart.
Kmart. What is Kmart again? All right, so I got a file saved, and I got it, and I'm going to open it from here. File contains link to other files. That's interesting. It's not supposed to. Okay, let's see if this works. It does change. Yeah. Well, that's the whole idea, to punch in your student ID, it will select, one of the 5 choices, for this question. And it does the same thing for all the other questions. So there are, a number of variations for each question. Depending on your student ID, you get, your particular version. They're one of 5.
That's sneaky.
It's not sneaky. It's only sneaky to people who have bad intentions to begin with.
I don't think any of mine changed when I put the number in.
It did not change?
Well, me neither.
I didn't notice
Just put the number in, and it changed the
Or
number
if
in
it
the
did,
cell.
it's just too subtle to notice.
It only changes this one line here. That's the only line that changes.
Okay.
Yep. So maybe it changed, it just did not, you did not look onto that line, at the time, so maybe that's why it did not show up. Hmm?
Yeah, I thought you were just like putting your name on something. I didn't think it was going to do anything.
No, actually that's something. This is the first time I tried that,
Watch for it next time.
Well, at that point, I already saved the file on my answers. Because
Yeah.
the first thing I did was right-click and save
Mhm.
file as.
Yeah.
So now it's written off onto my computer, my zip drive.
Yeah. But if I
Then
save
changed
again,
the number.
yeah, that's fine, because you have to save it again before you upload it. So that means by the time you upload the file, it already has, your customization, your own student ID. So you should be fine. As long as you save the file before you upload.
Well, if I saved the original file before I changed the ID number, how
It
is
doesn't
it
matter.
gonna?
It's written into the file. Is it on like sheet 4 or something?
Yeah, you just have to make sure you do this first before you trace it. That's the only thing.
Yeah, I did that.
Okay, then you should be fine. Yep. All right. Well, let's go ahead and take a look at this particular program. This looks awfully similar to the one that we have in the practice test, does it? Okay, with only one difference. This one has a return, and whatever it returns go back to the print, and then the outer statement is also just a print statement. Okay, but does it really change, anything? Does it really, introduce any new concept or new something that is new that we have not talked about before? Nope. It has all the same concepts as with, all the programs that we have done so far. So let's go ahead and see, how we can trace this program to find out, what it will do. So we'll go ahead and track it down in sheet 2. We do have comments here because we have stuff to print, and also there's a conditional statement and line number. The precondition, there's nothing to say because we do not have any global variables. And then we start to invoke, Atom. So that means we start execution on line 9. And we cannot have a return line number. We have to use return info in this case because the subroutine returns a value. Any questions from you guys? Any questions about the... No? Okay. All right. So the return info is to go back to line 9 and then finish it up. The rest of line 9 looks like this because we want to print the value that is returned by the subroutine. So that's why this question mark is taking the place of the invocation because that's a placeholder of the return value. We still have to supply the parameters. We have parameter x and parameter y. This one, it is a little bit easy because it is all passed by value. So that means you just have to supply those 2 values into column D and column E in this case. Once the columns are all set up, we can go into the subroutine starting on line 4. Line 4 asks, is x greater than or equal to y? And the answer is true. 92 is greater than or equal to 9. Then we move on to line 5, which is another print statement. But we don't know what to print until we are done with this particular invocation. That's why we have to set up return info again. We are going to invoke Atom another time. And this time we are going back to line 5 to continue what is left on line 5 to do. And what is left on line 5 to do is yet another print because we have to print the return value of this invocation of Atom. We also have x and we also have y here. Y is the easy one because according to this we are passing y to y. y has a value of 9, and that's why we're just passing the value of 9 to column H. X, on the other hand, requires a little bit of calculation. It is the floor of x divided by y. X is 92, y is 9. So if you want to calculate the floor, you can use the spreadsheet to help you, because you can always say, what is 92 divided by 9? It is 10.222. So that means, the floor is just 10. Yep. Question? No? Okay. So you can also use the calculator. Windows has a calculator. You can use the Windows calculator. Taking the floor is basically dropping the fractional part when the number is positive or non-negative. So that's you have a lot of tools to help you with the arithmetic part. Okay, we just optimize the columns and then move on. I noticed that not everybody changed the resolution of the screen when you took the test. When in the final, maybe you want to consider maximizing the resolution, because that gives you a lot more rows and a lot more columns, so you don't have to scroll around or use the tricks that I have to use in the class. It makes everything easy to track down when you have a higher resolution screen. I cannot do a high resolution thing here because people in the back would not be able to see what I'm typing. Okay, so now we go back to line 4 again, and we check, is x greater than or equal to y? Yep, it is still greater than or equal to y. Then we go to line 5 again. Now this time when we go to line 5, we can just copy and paste most of it. The only part that needs to be changed is the x. What is the floor of x divided by y? 1. Yep, it's just 1. And then we can optimize these 3 columns. And this will be the last time that we have to invoke Atom, because from here on, we'll just be finishing up and then returning from Atom. We start with line 4. X is greater than or equal to y is finally false. Okay? When that is false, what we want to do is to return x mod y, which is on line 7. Okay. What is x mod 7? X is 1, 7, y is 7, y is 9. It's 1. Okay? 1. The remainder of 1 divided by 9 is 1. So we are just returning 1. What do we do when we execute a return statement? We copy and paste the return info cell, and then we change the question mark to whatever value that we are returning. In this case, it is just 1. And we are done. We are done with the return statement. Then we get to line 8, which is the end of the subroutine. Okay, I punched it in the wrong window. Okay, this is line 8. And we just have to deallocate these 3 columns. But before that, we have to remind ourselves where to go to continue execution after the end of this subroutine. It is line 5. And line 5 now looks like this. After that, we can now deallocate the columns. In the test, you guys don't have to do the same thing as I do in the class, because it takes up a little more time. You can just, kind of X out, all 3 columns and, call it good. But in the class, I always do it like this because it's more consistent with my own notes. Now we continue execution on line 5. Line 5 looks like this now. I don't have any other invocations to deal with. I'll just go ahead and print a value of 1. Is this part okay? Because this is a part of the tricky part. Yep.
Well, I had a problem on the mod part. I thought it was 9 divided by 1, so I thought the remainder was 0. So
I did that too.
1 goes into 90, 9 times with no remainder. So I got the mod backwards, I guess.
You got the mod backwards. Yep.
It's used like all the other operators. It's used like all the other operators.
It's like a division operator.
Divided by y is the same.
Yeah, it's the same as a division, except you don't care about the quotient in this case. You only want to get the remainder part of it. Yep.
So like
In row 12, column I, where you just calculated the x mod y, for that I just put in like the actual values and didn't calculate yet until I moved to like.
Until you do it here. Then you'll be using the wrong values. You have to resolve the value at the time of the return statement. Okay, the value has to be fully resolved by the time you execute the return statement. It depends on what you actually turn in. I might give you partial credit for what you turn in. But this is this is what the computer actually does. Is it does resolve the value at the time of the return statement. So if you specify x mod y here, and go back here and then evaluate it later, the behavior of the program is actually different in that case.
What if you put in the actual numerical values, like print 1 mod 9, and then resolve it later?
That would still be not consistent with what the computer does, but in your case, it will still print the correct value because you fixed the value at the right time. It's just that you did not calculate it, at the time, right? But you should, calculate it at the time, because the computer actually does that too. It fully resolves the whole thing to a single value when you execute a return statement. Yeah. Okay. So in other words, in one case it does make a difference. Is what if y is 0? Okay, if y is 0, it's a division by 0 problem.
Yeah.
Now in this case, the way I track it down, the program would have crashed on exactly row 12 of the trace because I evaluate the division on row 12. But in your case, it won't crash until we get back to row 14 because that's the time when it gets evaluated. Okay. So it still makes a minor difference, whether you evaluate it at that time or you just take the values and then evaluate it later on.
Okay.
Yep. Mm-hmm.
On the pseudocode, why did line 9 change to 43.6? Wasn't it 92 to 9?
Yeah, it did change.
It got changed.
Yeah.
Oh, that's because I did something stupid here. I punched in a number that is, yeah, yeah, because I updated to the wrong one. Now I have to find out which one it will give me. Okay, there we go. Because I forgot to switch the window before I started typing, so the focus got onto the wrong window.
All right, just a little confused.
Okay, it is confusing.
Well, you made it.
Well, not the question itself, but when I changed, that value accidentally and updated these values, that did make it confusing. Okay, so we are after line 5, then we'll move on to line 5 is the only thing inside the conditional statement. So after line 5, we move out of the conditional statement onto line 7. So on line 7 here, we're returning x mod y, and x in this case is 10. 10 mod 9 is what? 1. Yep. So we will go here, and then we'll resolve the question mark to another 1, and not x mod y or 10 mod 10 mod 9. You really have to resolve the value to a single value at that time when you execute the return statement. Then from line 7, we move on to line 8. On line 8, we remind ourselves where to go back to, which is on line 5. And also, we have to deallocate the 3 columns that we allocated for this invocation. And now we continue execution on line 5. Line 5 now looks like this, which means we're going to print a value of 1. And then we move on to line 7 again. This time we are looking at 92 mod 9. What is 92 mod 9? It's 2. So we have to execute return 2 in this case by changing the question mark to a value of 2. And that's the end of line 7. We go to line 8. Same thing. We look up the line number of the return info. We go back to line 9, and then we deallocate the 3 columns. And now on line 9, it looks like this. We are going to print a value of 2, and we're all done. So, yeah, go ahead.
Y is 1 mod 9, 1.
What is 1 mod 9?
Y is 1 mod 9, 1.
Okay, because 1 divided by 9 has a remainder of 1, a quotient of 0. I have 1 candy, and I have a class of 9 students. So how do I evenly distribute the candies to all the students? Well, all the students will get 0 candies. And how many candies do I have left on my hand? 1. Yep. It's one of the trickier cases, because a lot of times, we assume the dividend is larger than or equal to the divisor when we do division, but in reality, it doesn't have to be that way. Did you guys talk about division where the dividend is less than the divisor in elementary school when they first talk about divisions? No.
Then you go into fractions, then you go into decimals.
Question?
Just saying we Googled it, because Google can actually do mods. So you just type in.
But there's an easier way because the spreadsheet can do mod too.
See, you tell these things after.
You show us this.
I think an advanced calculator probably has mod too. Let me see if I can find one. Yep. See, I got mod. But I'm not using Windows. That's why I said people should switch to Linux.
So they can pass your tests.
Mod, come on, mod. It's just the remainder. Division.
This is the first class I think I've ever seen mod.
Really? Yeah, but the concept of a remainder is not new though.
No.
Yeah. A mod operator is very, very useful in programming. Okay, so this is a little bit out of the context of this class, but I just want to introduce the concept because you will see that again if you continue to write programs, regardless of the programming language. Everything that you do in a computer with most programming languages has an implied mod operation in it. Okay, every time you add, there's an implied mod. Every time you subtract, there's an implied mod, and so on and so forth. It has to do with how we represent numbers inside the computer. Okay, now how many bits do you think we allocate to a single integer when you write a program? A bit is a binary digit, which is a 0 and a 1.
64?
8.
Oh, 8.
Okay, 8 is the smallest number, because 8 bits makes 1 byte, which is what we need to represent one character using the ASCII standard. Okay, now we have 16-bit integers, we have 32-bit integers, and that's why we have quote-unquote 32-bit architectures. Basically, internal to the processor, it can add 32-bit to 32-bit, it can subtract 32-bit from 32-bit numbers, and so on and so forth. Okay, and now we have 64-bit architectures, which are basically mostly emulated. In other words, internal to the processor, it only has a 32-bit calculator, but it can combine operations so that it looks like it is actually performing 64-bit operations. But the point is, it is still not limited. In other words, when you use an integer other than in this class, the number of bits allocated to represent the integer is fixed. Okay, it can be a larger number. Okay, maybe in the future we can have 128-bit integers, but nonetheless it is still limited to 128 bits. It is a finite number of bits. Okay, now what does that have anything to do with what we are doing here? Well, think about the number of values that can be represented when you only have a fixed number of bits. Okay, let's go ahead and this is a digression. But it is definitely related to programming, regardless of the programming language. So that's why I want to spend a little bit of time to talk about it, even though it is not directly applicable at this point. Okay. How many things can I represent using only 1 bit? 1 bit is 1 binary digit, which is either a 0 or a 1. 2 things. Okay. So with 1 bit, we have 2 combinations. Then the 2 combinations is basically 0 or 1. Okay. What about when we have 2 bits?
4.
We have 4 combinations, and the 4 combinations are 0, 0, 0, 1, 1, 0, and 1, 1. Is that making any sense? Because each digit can only be a 0 or 1, so every time we add 1 more bit, we just multiply the number of combinations by 2 compared to the one before. Now we can skip 3. We can just go straight to 4. So with 4 bits, how many combinations do we have? 16, because 2 to the power of 4 is 16. So 16 combinations, 0, 0, 0, 0, 0, 0, 0, 1, blah, 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 blah. And the last one is 1, 1, 1, 1. Okay, but there will be 16 of those. Okay, so when we are dealing with, let's say, 32 bits, obviously that's going to be a huge number. But nonetheless, the number is still finite. Okay? Because with 32 bits, we can have 2 to the power of 32 combinations. Okay, great. We have 1, 2, 3, 4. Okay, instead of actually writing it, I'm just going to paste it. Okay. So we have 8 bits, 16 bits, and 32 bits. And the last one, the last combination is going to be 32 1. Okay, but that's a huge number. It's 2 to the power of 32. It seems like a big number, but it's not. Okay, because 2 to the power of 32 is approximately 4 point something billion. Now 4 point something billion is a big, huge number. Maybe 100 and 200 years ago, but today it's not a huge number anymore. What is world population? 1 point something billion. Okay, so it's still big enough to represent the number of people in the world. What is our national deficit? Okay, so this is just billion. Okay, it's off by 3 zeros. Okay, so how about hard drives? What is the largest, or what is the quote unquote standard capacity these days for a 3.5-inch hard drive? At least a terabyte these days, right? I mean, you can probably still find sub-terabyte hard drives, but those would be like bargain deals, because the shops or the stores are just trying to get rid of all those drives. Okay, but when you buy a brand new computer, most of the time they have a terabyte drive already. Okay, what is 1 terabyte compared to 1 gigabyte? 1,000 times. Okay. So that's the problem, because older operating systems or older file systems, to be more specific, like FAT32, what do you think the 32 comes from? 32 bits. Okay, so older file systems cannot deal with big hard drives because they cannot address the entire drive because the internal limitations.
Is that why there's a file size limit?
Yes, that is exactly why in FAT32 the file size limit is actually only 2 gigabytes, not 4 gigabytes. Yeah, because they were using signed numbers, which takes away 1/2 of the positive numbers because you need one. Yep, exactly, because 1/2 of the combinations are used to represent negative numbers. Now it's.
As long as you partition a terabyte drive, you can still use it.
Yes, but each partition can only be up to a certain size when you use FAT32.
Yeah.
And the annoying thing about FAT32 is one single file can only be up to 2 gigabytes. So a lot of files these days are not that small anymore. One video file is can potentially be more than 2 gigabytes. If I record about, I would say about 100 minutes continuously, it's going to be more than 2 gigabytes already. Yep. So, but the point is, it is still limited. So the question is, let's just say that we are dealing with 2 bits. What happens when you add 1 to 1 1? 1 1 is the largest number that you can represent using 2 bits. When you add 1 to it, what do you get? Well, you have a carry, but in high-level programming, you don't see the carry. It goes all the way back to 0 0. Okay. In other words, 3 plus 1 equals to 0. That doesn't work, right? I mean, that's just weird. Okay. Well, fortunately, we do have larger numbers, 32-bit numbers. But guess what? The same can happen to 32-bit numbers. Because if you add 1 to the binary number that has 32 ones, guess what? It rolls back into 0. Now, what does that have anything to do with mod? It's just a built-in mod. Okay, with 32-bit numbers, there's a built-in mod operation of mod 2 to the power of 31. And then when you use 16-bit numbers, there's a built-in mod after every operation of mod 2 to the power of 16, which is 65,536. Okay, so that's why mod is very important in computer science, because everything that you do with a limited number of bits to represent an integer, everything has an implied mod already inside it. Okay, it's just that most of the time we don't want to think about it. It doesn't make it go away. Okay, so you will see this again, because when you run out of the range of values that you can represent, then you will wrap around. But the wrapping around is actually the mod operation, itself. All right. So this is all done. Let's move on to the next question. Are you names of card, for the file names, so that the the name of the subroutine do not imply what it is supposed to do. Yeah, otherwise, that kind of takes the whole fun out of the whole thing.
Oh, so fun.
Oh, by the way, did you guys realize what this program does? What is it doing?
Counting down.
No, it's not counting down per se. It's actually doing base conversion, or I shouldn't say base conversion, but it is. It's going to print out a number. In this case, it's printing out the value of 92 in base 9. That's what it's doing. Okay. When you look at the trace, you have to read it in a certain way. Okay, let's go move on to sheet 2. When you look at sheet 2, when you look at 112, 112 is actually the representation of the value 92 in base 9. Okay. Do you guys want to know why? No. Nobody cares. Okay, 112 in base 9 represents 92. Now, why is that? Okay, let's look at decimal numbers first. Okay, when you look at the decimal number 92, what does the 2 represent? 2 ones, right? 2 of ones. And what does the 9 represent? 9 tens. And if we have more digits, it will be the hundreds, the thousands, the 10,000s, and so on and so forth. In other words, each digit is only representing the quantity of a particular power of 10 with a decimal number. 2 tells me how many 10 to the power of 0 do we have. 9 tells us how many 9 to the power of 1 do we have, and so on. If you have a decimal point on the other side, it will be negative powers of 10, okay, and so on. So that's how we read the numbers. When you deal with a number that is not of base 10, that's okay. It's the same way. Because this 2 is telling us how many 9 to the power of zeros do we have. 9 to the power of 0 is 1, so we have 2 ones in this case. What about the next one? It tells us how many 9 to the power of 1s do we have. 9 to the power of 1 is just 9. And the next one tells us how many 9 to the power of 2s do we have. In this case, 9 to the power of 2 is 81, so we have 181 in this case. So this is representing the value of 81 plus 9 plus 2. 81 plus 9 is 90. 90 plus 2 is 92. So this number in base 9, 112, is representing the same value that we write out as 92 in base 10. Is that working out okay? Okay. Remember I said something about our currency system. If you know how to make change, given a certain amount, you already know more than what you need to know for base conversion. So the program does that. For those of you who are curious, maybe after this class, you can look back into the algorithm and try to figure out, how it gets the job done. Okay. All right. So that's that for this particular one. And we'll go ahead and work with Civic. And yes, Atom is actually a car. It's the Ariel Atom. Yeah, I just want to look at it.
You know that FT86 is a Scion now?
I hope not.
It is.
This is the Atom. It's a $50, close to $60,000 car, I think.
Street legal too.
Huh?
This is
Street legal.
Sorry?
Street legal?
Yeah, it is street legal. It has what? It has headlights. It has headlights. This one is sold $62,000 for this one. But $62,000 is a lot of money for a professor. Okay, trust me, I don't get paid that much. But for other people, $62,000 is chump change. You see all these people driving like 7 Series, BMWs or S500, Mercedes-Benz and whatnot. Those cars are what, 120,000-ish, around that
Around that ballpark.
Around that ballpark. Yeah, but those cars are no fun to drive. I mean, it's automatic. Has air conditioning. And you can't even see anything, right? All you can see is the dashboard. The wood panel stuff and whatnot. With this car, you see the road. You actually see the road. You see the suspension. You see the corner. You see the apex. If you're doing the track
You see the
thing.
truck about to hit you too. You see the truck coming from behind to hit you.
You can probably slip this under the
you
truck.
could.
You just have to angle it
A
right.
little Fast and Furious action.
Oh, I'm surprised that they don't have this car in Fast and Furious. Because this car will smoke anything up to maybe $120,000 easily. I think if you look at the specs, it's 0 to 60 miles per hour time is like 3 seconds or a little less than that.
I think it's like 2.9 or somewhere. Right
Yeah,
around 3.
yeah. Because when you go for the track, if you want to drag this car, onto a drag, the recommendation is don't start with first gear. Because guess what? You cannot shift that fast. So they say start with second gear if you want to drag it. Don't start with first gear, because the amount of time that it takes to shift gear is counteracted, by just starting with second gear without having to shift that first gear. Yep, $60,000. You can park it next to like a $150,000 Porsche, and smoke the Porsche any day.
Is it all-wheel drive or rear-wheel drive? What
It is. It's rear-wheel drive.
Oh, it is.
Yeah, it is.
Okay.
Yep.
It's a lot better.
Yeah, it's very balanced. I mean, you should watch it. There's a whole bunch of YouTube clips on this car.
Top Gear did one of it.
Yeah, Top Gear did one. It's funny. The Top Gear one is really funny. Okay. So now that you guys are awake, let's move on to the Civic one.
That's a downgrade.
It's accessible for most people.
It's a Lego chip.
You can go to Craigslist, spend $2,000 on an EK or an EG, and then spend another $20,000 on it to soup it up. All right, same deal here. You have to enter your student ID to customize the question. And this is the question. This one is not really intended to be tricky. This one is really just testing whether you know how to pass parameters of the right type. And the key is to make sure that you know which subroutine it is invoking, because here we're invoking EK, and then from EK we invoke EG. Those are basically code names of different chassis or generations of Civics. Most people don't refer to those things. It's kind of like I think it's a Japanese thing.
The EG is the best one. The EK is too. The weight distribution on it is a little too big.
Yeah, they always get too big. Eventually. All right, so let's go ahead and take a look at this one. Find out what it does. Okay, do we need comments? We do not need comments in this case, because there are no print statements and there are no conditional statements here. So we can start right off with just line number. There are no global variables either, so the precondition doesn't really have much to say. And then we can start with the first line that is outside of the definition of a subroutine, which is line 20. Line 20 doesn't do much. All it does is to invoke the stub subroutine. The stub subroutine, the only thing it does is to supply us with a local variable I, but we still need a return line number so that we can return back to post in this case. A local variable I starts with an unknown value. It is important that the unknown value be an unknown value. So I will look for not only the column for I, but also to look for the initial value of a question mark, because that is a very important concept. So with some programming languages, when you start to use a local variable, you can kind of assume that it is initialized to 0. There's a default value. But when you program in C, there is no such thing. When you start to use a local variable, it starts with a value, but you don't know ahead of time what that value is. So that's why it is very important to represent that value with an unknown or a question mark, so that we know, okay, if your program relies on the question mark like this, then it is probably not doing something right. You have to initialize that value first before you actually do something. Okay. So here we start with the first line inside stub, which is line 17. Line 17 is initializing I to a value of 10. And then we move on to line 18, which is invoking the subroutine called EK. So that means we have to have return line number, because this entire program does not have a single line of return statement. So that's why we can use return line numbers for the entire program. The return line number is the line that is logically following line 18. In this case, it is line 19. And then we need additional columns for all the parameters as well as local variables of EK. EK has 3 items. It has X, which is passed by value, Y, which is passed by reference, and also I, which is a local variable. We'll deal with the local variable first because it is the easiest one to deal with. X is passed by value. In this case, I have I minus 2 to pass to X. I has a value of 10, so that means X will have a value of 10 minus 2, or 8. Y is the trickier one. Not really tricky because it's just passing by reference, but I use I, local variable I, to specify parameter Y. Local variable I lives in column C. That makes parameter Y an alias of the same column. So Y is also known as column C in this case. Any questions? No questions? Okay. After we set up the columns, we go into the subroutine EK, start executing on line 10. Line 10 doesn't do a whole lot. All we are doing is copying the value of Y to I. Y is a reference to column C. Column C has a value of 10, so I, as a local variable, starts with a value of 10. Any questions? No? Okay. And then we move on to line 11. Line 11 is going to invoke EG, and we'll need some more columns here. When we invoke EG, we have to set up the return line number column. The invocation is happening on line 11. Line 12 is the line that is logically following it. And then we have to set up the parameters. We have 2 parameters. One is X and one is Y. What I use to pass to X is I. I is my local variable. My local variable I lives in column G. So that makes parameter X of EG an alias of column G. Is that okay? Any questions about this step? No questions? Okay. Y, on the other hand, is passed by value. So if Y is passed by value and I use X to pass to Y, all I need to do is to look up X. X is column E. It has a value of 8. And I'm just copying the value of 8 to Y because it is passed by value. Are we doing okay so far? Yes? Okay. Then we move on and continue execution inside EG, which only has 1 line. I did the same thing again. I have to undo. Okay, so on line 4, there's only one thing to do. We have to evaluate X plus Y first because it's the right-hand side of the assignment operation. X is also known as column G. Column G has a value of 10. Y is my passed by value parameter. It has its own value of 8. 10 plus 8 is 18. What am I updating? I'm updating X. X is an alias of column G. So column G is the one that is now updated to a value of 18. Are we doing okay so far with this step? Okay. So these are the things that I'm looking for. These I'll be looking for, but they're not as important. I'm looking for this one. This is one of the very few things that are very, very important in this trace is which column are you updating? Okay. Now we move on to line 5, which is just terminating the whole thing and reminding us that we have to continue execution on line 12. So we'll go ahead and mark this is the end of this subroutine execution. And just change the formatting like that. Now we're back to line 12. Line 12 is invoking EG again, but this time I switched the parameters around a little bit. So that means I have to set up the same 3 columns. The return line number is line 13 because line 11 all the way up to line 14, they're all sequential. So the logically following line is just the next line. Let's see what will become of X. I use X to specify X. The X on the left-hand side refers to the X that I have as EK. the x of ek is column E, so that means the x of eg is going to be also known as column E. Are there any questions about this step here? I just passed a parameter passed by value to me by reference to another subroutine. Is that okay? Okay. What about y? I use y plus 1 to pass to y, but the y on the left-hand side refers to my own y. I'm still executing inside ek at this point. So that y really refers to column F. Column F is referring to column C. Column C has a value of 10. 10 plus 1 is 11. Is that okay? Okay. And after I set up the columns, I go into EG, starting on line 4 again. Line 4, once again, is trying to calculate the sum of x and y. X is also known as column E, which now has a value of 8. And y is, y has its own value of 11. 11 plus 8 is 19, and we're going to update x. X is also known as column E, and column E is the one that is now updated to a value of 19. Is that okay? Okay. Then we move on to line 5, which is just telling me I have to continue execution on line 13, and also we have to remember to mark these columns as freed or not available at this point. Now we are on line 13. Line 13 is invoking EG one last time, so we have to set up the same 3 columns again. Oops, not these. These guys. Line 14 is the line that is logically following line 13. And what are we using to pass to x? We are using y of ek to pass to x of eg. Y of ek is an alias already. When you pass a by reference parameter, also by reference to somebody else, you are just passing the alias along. So in this case, we're just passing aka column C along. What am I passing to y? I'm passing I minus 1 to y. I of ek is column G, which now has a value of 18. 18 minus 1 is 17, so y of eg is going to be 17. Are there any questions about how I set up the 3 columns in the third invocation of EG? No questions? Okay. We move into the subroutine starting on line 4. Line 4 is adding x and y. X is also known as column C. Column C has a value of 10. Y is column J, has a value of 17. 10 plus 17 is 27. I use the 27 value to update x. X is also known as column C. Column C is the one that is now updated to a value of 27. Any questions about this step? So that means what I'm looking for is the update of column G, the update of column E, and the update of column C at the right time. Now, if you have a column for comments, even though it's not needed, and shift everything over, that's fine. I'm not looking for the absolute location of those values. So I'm just looking to make sure that it is consistent with the execution of the code. So if you have column A being a column of comments, it's not going to be an issue. Then we move on to line 5. The rest is just cleaning up. On line 5, we are at the end of the subroutine. This reminds us to go to line 14. Then we can deallocate these 3 columns. We are now back to line 14. Line 14 is also the end of a subroutine. This time we look up column D to tell us to continue execution on line 19. Then we go ahead and free up these 4 columns. Like so. And now we are back to line 19, which is also the end of a subroutine. So now we go ahead and remind ourselves to continue execution at post, and then free up these 2 columns as well. Okay. Are there any questions about this trace? No questions?
How do you
Oh, what gets changed?
If you look at sheet 3,
Yeah, sheet 3 gives you the alternatives. So basically, this is the line that gets changed, depending on your student ID. If you change this one, I probably should not do it here, because if I did it here, then it will, the answer does not match the student ID. But they're all about the same. If you go to sheet 3, the only difference is, what do you pass to X initially? They're all just minor additions or subtractions of I. Yep.
Why are there only 5 variations?
Because I just feel lazy and not give like 25 or 30 options.
Well, I mean, how does it determine? What does it use to determine which variation you get?
Oh,
The last
it's the equation.
This is the last
It's this
variation?
equation here.
Oh, okay.
Yeah, I use a spreadsheet function to do it. You can see I actually use the mod function here too. I basically multiply your student ID, which is the cell C1, by a prime number. In this case, it's 17, and then mod it with the number of possibilities. In this case, it's 5. So that basically determines which one. The rest is just the formality that I need to make this work. But the engine is multiplying it by a prime number and then mod it with the number of questions. It has to be a prime number, because if it's not a prime number, it is possible that some of the options will never be used. Okay. Any other questions? Yep.
Why do you multiply by a prime number?
Because if I don't use a prime number and a number, okay, let's
Why
say,
do you multiply at all?
just modding it by 5.
because then it will be too easy for people to figure out. But multiplying by a prime number is is a pseudo-random generator. Basically, it's a pseudo-random pattern. There's no such thing as true random. Okay, so that's done. I'm saving this file and close this window and then close this too. Moving on to the next question. And this one is FT86. The FT86 is not a production car yet. It's a concept car.
Actually, it is. The Toyota version is already in production.
Is it rear-wheel drive?
No, it's rear-wheel drive, but it's a Scion, though. It's under
Oh,
Scion
oh, they
brand.
make it. They market it under the Scion,
Yeah.
brand name.
The Subaru one is not in production yet, though.
Okay. Did they keep the Boxer engine in the concept car?
Yeah, it's still there.
Okay. Does it price like a Scion, or does it price like more like a mini Lexus?
They said it'd be like between. It wouldn't be like an LFA, but it'll be like in between.
Okay. You guys can look it up. Look up your FT86 and find out what it is.
Do it for 'em.
Because people are falling asleep again.
A shiny car like you love.
Well, I want to look at it. Oh, they have a club already. Oh man, these people are just crazy.
Yeah, that was a teaser on Car and Driver.
Mhm. But just to summarize, what it is, it's a small coupe with a rear wheel drive drive axle, and instead of using a inline 4 engine in the front, which is kind of more conventional of Toyota, it uses a Boxer engine that is made by Subaru. So the Boxer engine is a very flat engine. Has anyone ever opened the hood of a Subaru? Any Subaru, doesn't matter which one.
They used to have an SVX.
Hmm?
They used to have an SVX.
Okay, it's the same thing. The layout of all Subarus are identical. Okay, you pop open the hood, do you see the engine? You don't see the engine. All you can see is the intake manifold of the engine. Because in order to see the engine, you kind of have to look a little bit sideways. You just have to follow the manifold, and then you can see where the engine is. It sits really low, and then the nice thing about that is one, it lowers the center of gravity, and the second thing is it mates to the transmission really, really well, because the transmission sits right behind the engine. So it's a neat little design. The name of a Boxer engine comes from the the motion of the pistons, the way they move. Because with an inline four engine, the pistons move like this. The four cylinders move like this. In a boxer engine, which is also called horizontally opposed engine, the two cylinders, there are two on the right hand side and two on the left hand side, and they go like this.
So it has like because my Subaru had a flat six. So
If you have a flat six, then
this one has like a flat four.
I don't know how a flat six would work. I don't know how they box.
is like this,
right?
And then a flat six is like this,
right? But with a flat four, the motion looks like two boxes practicing, and therefore the name of a boxer engine.
Gotcha.
Yep.
Technically, on a boxer engine, the opposing cylinders move away from each other
and
towards each other, rather than back and forth. So that the two front ones move out together, in together. The two rear ones the same thing.
That would make the engine balance better.
Yeah.
Yep.
The whole engine shaking back and forth.
Some people claim that from listening to the exhaust note of a unmodified car, they can tell whether it is a flat engine or a flat six engine or flat four or not.
But flat fours do tend to sound different.
They do. I have had a Subaru since 2000. At one time, I actually had two, and I could not I could not hear the difference between that and my other cars. My ears are not well trained for that. It does make maintenance more of a hassle because your spark plugs are not that easy to access anymore.
Yeah, you have to actually, like on mine, you had to take the entire engine out to get to the spark plugs.
Oh, that's there's a couple ways you can do it. You can have the pump the wheel off. And
You can hire an octopus.
Miles good were over. They take you for like
But anyway, the FT86, is supposed to have a small displacement, a boxer engine, and the car is supposed to be light, so it doesn't need a lot of horsepower to get going. You can put 500 horses, behind a Hummer X2, and it's still not a fast car.
You can outpace that car walking.
And as soon as people can get that car to roll, it's time to pull over to a gas station again. In these days, it's gonna hurt. $4, even at Costco. Costco is only this close to $4 now per cylinder. But diesel gives you more energy, so it does give you better miles per gallon. If the price is about the same, then diesel actually wins in terms of economy. Yep. Diesel engines are also more durable in general. All right. Okay, so this is the one that probably will take more time, because this one actually has a little bit more interaction. And then when you look at sheet 2, the array is already pre-initialized. This is actually making it a little bit easier than before. So let's go ahead and track this one down and see what it does.
I thought the arrays had to be like in order or whatever.
No, well, this is not a sorting. This is not a binary search algorithm, so there's no need to make any assumptions.
Okay.
Yep. All right, so we'll go ahead and trace this and find out what it does. Okay. Do it in sheet 2. And start with line 18. Oh, do the same thing. Same thing. No. Okay, we start execution on line 18. Line 18 doesn't really do anything except we have to invoke FT86 first. So this time we have to be careful because the subroutine FT86 does return values. So that means we cannot use return line number, and we have to use return info in this case. When we do get back to this line, which is line 18, we have to print to finish up. And that's how we represent, the return info. What else do we have to do when we get back on line 18? But on top of that, we also have to pass the parameters. There are two parameters to pass and one local variable to set up. So we have A, which is passed by reference, In this case, I use array B to specify parameter A. Array B takes up column C to column E, and as a result, parameter A is an alias of the same columns. It is column C to column E. Parameter I is passed by value. In this case, I use 0 to specify that parameter. And we have one more thing to do. We have a local variable t, which always starts with an unknown value. Okay. So are there any questions at this point about the trace, how we set up the columns, the parameters, the local variable, and also the return info cell? Do you guys have any questions? No? Okay. All right, so now we can continue execution inside the subroutine, which is starting on line 5. Line 5 is asking, is I greater than or equal to bar A bar minus 1? Well, bar A bar is the same as bar B bar because A refers to the same 3 columns, and bar A bar, so that's why bar A bar is 3. 3 minus 1 is 2. I has a value of 0. 0 is greater than or equal to 2 is false. We have to go to the else. The else, starts on line 8. Line 8 is asking another question, another comparison. And I think we need to make this a little bit wider to accommodate that. Is A bracket I greater than A bracket I plus 1? Okay, so that's a little bit, it takes a little bit more work, on my screen because I don't have, enough width to do it. I is 0 at this point. So we are comparing A bracket 0 to A bracket 1. But A is the same as B. Array A is basically array B. So we are comparing B bracket 0 to B bracket 1. Is B bracket 0 greater than B bracket 1? No. So the answer is false. The answer is false on line 8. Now, when the answer is false on line 8, it's good because we can skip around, from line 9 to line 12. We can skip all the way to line 14. Line 14 is returning the value of invoking ft86 again. I cannot return anything at this point because I have to invoke in ft86 again. So now we have to set up those columns. Okay, we have return info again. Return info. Oh, okay. No wonder it doesn't look right. I swapped the characters. We have array A, we have parameter A, parameter I, and also local variable t. Local variable t always starts with an unknown value. I use I plus 1 to specify I, which is column H at this point, has a value of 0, so the new parameter I has a value of 1 to start with. And A is passed to A. Since A is already passed by reference to me, I'll just pass the reference along to the next invocation. Return info tells me what else I have to do on this line. This is line 14. When we come back, we have to return whatever was returned to me. So we have to say on line 14, just return whatever the question mark is. And that's how we set up these 4 columns. Do we have any questions about how we set up column J to column M on line 14? Is that okay? If there are no questions, we'll move on and actually try to track down, what we do inside the subroutine. And this may be a good time to split up the screen because otherwise we can't really see, everything that we need to see. And even so, we still don't have enough space to do it. Okay. We start from the beginning of the subroutine again, starting on line 5. And again, we are comparing I to bar A bar minus 1. And the answer of that is, it is still false. That's right. Because bar A bar minus 1 is 3, I has a value of 1, 1 is greater than or equal to 2 is false. Then we go to line 8 again. Line 8 is now comparing A bracket 1, because I is 1, to A bracket 2, because I plus 1 is 2. Is that true or is that false? Okay, let's go ahead and take a look at the array again. This time it is true because we are comparing column D to column E. Okay, so we change this false to a true. So that means we have to go through this junk here, to do all the calculations. All right. Well, that's okay. We can just track down each one and do the operation. On line 9, we want to make a copy of A bracket I to T. A bracket I is B bracket I. I has a value of 1, so we are talking about B bracket 1, which has a value of 23. So T will store a value of 23 on line 9. We go to line 10. Line 10 is going to copy the value of A bracket 2 to A bracket 1 because I has a value of 1. But since A is a reference to array B, we are actually just copying this 3 over to the 23. So as a result, we update column D to have a value of 3. That is the important part. Okay, we are actually updating the array itself because we are accessing everything through parameter A, which is passed by reference. That's the whole point of passing by reference, is it gives you a way to modify something that is not your own local variable or parameter. And then we move on to line 11. Line 11 is going to copy the value of T to A bracket I plus 1. I is 1, 1 plus 1 is 2, so we are actually updating A bracket 2. But since A is a reference to array B, we're actually updating B bracket 2. So B bracket 2 now has a value of 23 because 23 is the value of our local variable T. And then on line 12, we have to invoke the subroutine one more time. But this time it is a little bit tricky, just a little bit tricky, not too. Okay. Because in return info, you have to say which line we are on, which is line 12. We have return to do, and whatever the value returned is fine. But remember, there's a plus 1 after that. So you got to remember there's a plus 1 after that because we are on line 12 instead of line 14. After that, everything else is pretty much the same thing. We have to set up parameter A. Parameter A is still the same thing as before, which is also known as column C to column E. Parameter I is just 1 more than before. It is now 2 because it was 1 before. And then we have local variable T, which starts with an unknown value, just like before. So our current context becomes this part here. And then we continue execution inside the subroutine on line 5. On line 5 here. And on line 5, we have to do the same thing. We have to compare I to bar A bar minus 1. Bar A bar minus 1 is 2. I is 2 as well. 2 is greater than or equal to 2 is true. So that makes it easy because we just have to go to line 6 in this case to return a value of 0. When you execute return 0, you look up return info, you copy and paste it, change the question mark to a 0 in this case, and you're done. You do not simplify this 0 plus 1 to 1, not at this point. In other words, when you execute a return statement, the only thing that you do is to evaluate what value you're supposed to return and then replace the question mark with that exact value. You do not do any simplification here, and you do not do any calculation. You do not represent this as 0 in any other way. You just say it is a value of 0. After line 6, we get out of the outer conditional statement, and then we get all the way to the end of the subroutine on line 17. On line 17, we remind ourselves that we have to go back to line 12. And line 12 looks like this by the time we get back to line 12. After that, it is time to clean up the columns that we allocated earlier. And we just have to deallocate every single one, like that. And now we're back to line 12. But line 12 now looks like this. In other words, we are now going to execute return 0 plus 1. But we're executing it in a different context. We're returning 0 plus 1 in this context, which means we take this return info cell, and then we copy and paste it, and change the question mark to the value of 0 plus 1. 0 plus 1 is just 1, so we just put a 1 here. And we are done with line 12. When line 12 is done, we get out of the inner conditional statement. And then since this is the only part of the outer conditional statement, we also get out of the outer conditional statement. And now we get all the way to the end of the subroutine on line 17. By the time we get to line 17, we do exactly the same thing. We remind ourselves where we're supposed to go back to. We should go back to line 14. And then we also say that, okay, these 4 columns are no longer useful. So we'll go ahead and deallocate those 4 columns. That. And do you guys have any questions back there?
I was explaining the return useful comments.
Okay.
Because he makes me up that.
Ah, okay.
And why you put the print statement from Adam all the way over in the comments.
Yeah, when you execute a print statement, then you put it inside the comments column to indicate what value you are printing. But before you do the printing, you don't put anything into the comments column. So it's really just for indicating the result of comparisons, the Boolean evaluation, as well as when we get to a print statement, you also use the comments column for that purpose. Okay. So now we're back to line 14 because the return info cell tells us to go back to line 14. On line 14, we are okay. By the time we get back to line 14 looks like this: return 1. But the context to execute that return statement is actually here. So we have to take this return info cell and then copy and paste it here and then change the question mark to 1 because we are executing return 1 in this case. But we don't execute a print statement at this point. So we basically finish line 14. That will get us out of the inner conditional statement. And that will also get us out of the outer conditional statement. Now we are back on line 17. On line 17, there are 2 things to do. One is to remind ourselves to continue execution on line 18, which now looks like this. And then the second thing is to deallocate the columns that we allocated for this invocation. Like so. And now we are back to line 18. When we are back to line 18 looks like this. We know exactly how to do that. We print a value of 1 to the screen, and that concludes the entire thing. Are there any questions about this particular trace? It's a little bit longer than the other ones. This one takes up 26 rows instead of something less. It's still not too many, because when you maximize the resolution of your screen, you have a much better view than I do when I do it here. Are there any questions about FT86? Nope. Okay. So we'll go ahead and save this file. So everything that I do today is saved to today's folder. I just have to upload that folder at the end of the class, and you guys have the solution to the test. We'll have one more question to go, which is question number 4. Question number 4, come on, show up. There we go. Okay, question number 4. Let me say first, it's STI. The STI is a Rowley car, just so that we cover the naming of the subroutine first. Okay, so this one has WRX. WRX stands for World Rally. WRC is challenge.
Yeah, I think the X
champion.
is extreme or something. I don't know what the X stands for.
Okay, but it's a rally car.
Yeah.
The regular WRX is supposed to be quote unquote a rally car, but they actually just borrow something from a rally car, but it's not really hardened as a real rally car. The STI version is a quote unquote real rally car with upgraded components. So the car is an all-wheel drive with a computer-controlled system to divert the torque to the right wheels, and I think it has 300 horsepower or so.
Yeah, right.
Yeah. And those cars are designed for rally racing, not really for street driving.
We still do it.
Rally racing is not really that popular in the United States, but it's really popular elsewhere in the world.
Yeah.
I think the Europeans are really well into that. Asians, I don't know so much, but I think they do a lot of races in Africa too.
Yeah.
Yeah.
I don't know why, but I think Drifting Initial D is Asia's version of rally racing.
Well, but that's
Well,
paved
that's
road. It's not
yeah.
It's not dirt road. Dirt road is a whole different story. Yep. We do United States, NASCAR is popular compared to
Le Mans is catching on a little bit. Le Mans is catching on just a little bit.
Le Mans. Yeah.
But not too much.
NASCAR, left turn, right? More left turn.
Circuits too, not all.
You've heard the joke. How do you get away
We're
from
gonna
a
say goodnight
NASCAR
show up
fan,
someday.
right? Just turn right.
Well, I don't doubt it that it's a real sport because when you look at a driver, they're always sweating, but it's not as fun to watch as compared to rally races or Grand Prix. Using
NASCAR, NASCAR, if you look at it, it's not fun watching.
Mm-hmm.
The actual participation in NASCAR is grueling. It's the most one of the intense things you probably ever do to your body is NASCAR racing.
Well, the same thing with Formula One. With the Formula One, they don't do stick shift, because they have the paddle shifting. Yep. The steering wheel is like this big, and it's not a circle either.
It's like a bow tie kind of.
Yeah, because the ratio is it close to 1-to-1 with the Formula One?
Just about, because if you watch, when I used to watch, what's his name, Schumacher race, it just 1-to-1 ratio almost. The slightest touch is cramped.
You're off
Yeah, you're touching a wall.
Yeah, do not sneeze. Because your car is going at easily 200 miles per hour, and the steering wheel is 1-to-1.
You got open wheels too. And you got open tires too.
Yep. Yep, that's dangerous.
That's fun. It's like go-kart racing, just a real go-kart. Nothing.
Yeah, I don't do that. I don't have
What?
any skills.
Oh, you did? What was it?
The closest thing most people can do is basically autocross, parking lot Grand Prix. There's one coming up on Sunday. This is Sunday, the 17th. I think they do it in Mayfield these days. They just because the airport, the military airport is closed down, so they use the runway and also the other parts of the paved part of it, for autocross events.
I was there a couple of years ago and they had the Blue Angels show up.
Mm-hmm.
That's when I was at Mayfair.
On the autocross day?
No, just.
Oh, okay.
Had the Blue Angels show up.
Yeah, I know because the Miata Club actually has a club championship, this Sunday too, but I'm not going.
You're a Miata?
I have a Miata.
What year?
Huh?
What gen?
It's a NA 96.
Turbocharged that thing.
No, it's NA. It's naturally aspirated. NA. Yep, it's NA and an NA. All right, so this is the last one. Let's go ahead and deal with this one, and we'll be done. All right, so this one is actually not that difficult. The only tricky part about this one is this line here. Okay, if you have to look at this question and go, okay, what is difficult about this question? That's the line. Okay. Okay. Now, let's just run the program, get to that line, and then I'll explain why this is actually about the same as all the other questions. It really does not introduce a new concept. It is the application of the same concept but on something that is different. Okay, so we have comments, we have line number, and then we have no global variables for the precondition. We start execution on line 17. Okay, those are all the easy stuff. And we have return line number in this case because we don't have any return statement inside WRX. So we return to post when WRX is done. And then we have to set up the parameters. We have parameter I and parameter J that both passed up by value. Okay, 3 goes to I, 5 goes to J. Okay, 3 goes here, 5 goes here, and we are done with setting up I and J. Then we go into the subroutine starting on line 9. Starting on line 9. Line 9 is just evaluating, what do we do on line 9? Can we know whether we should go into the loop or whether we should get out of the loop at this point? Do we know? We don't. Okay? We do not because the condition that we depend on to tell us whether we should go into the loop or get out of the loop is the result of invoking STI. So we cannot make the decision at this point. We have to invoke STI first before we know whether we should go into the loop or whether we should get out of the loop. So that's why what we need to do on line 9, at least the first time we get to line 9, is to say, well, we don't know what to do at this point because it has the invocation of a subroutine that returns a value, and what I need to do depends on the value that is being returned. So in this case, we have to say okay, we have to invoke STI, which means we need a return info in this case because I know that I have to get back to line 9. When we get back to line 9, this is what is left to do. Is that okay? We are using the same concept that we normally use in print, in assignment statements, and sometimes even in return statements. But we are applying the same concept to a while statement. We can do the same thing to an if statement. In other words, every time you see the invocation of a subroutine of something that returns a value, every time you see it appearing in the context of something else, just use the return info here because you will have to get back to that same line to continue on that line using the value that will be returned later on. Is that okay? No? Okay, the invocation is basically, okay, this part here is a value to be determined by the invocation of STI. And that's why I do not know at this point whether I should go into the loop or get out of the loop. But one thing I do know is I have to invoke the subroutine first. So that's why, over here, I have to do the invocation of the subroutine called STI. Whenever you invoke a subroutine that returns a value, you have to use return info so that you know where to go back to. Because not only do I know that I have to go back to line 9, I also know that there's something else on line 9 to do, which is deciding whether to continue, go into the loop or get out of the loop. So that's why line 9 looks like this, because the question mark is a placeholder, so that the return value of STI goes here. Then we have to set up the parameters just like the usual stuff. We have x and y here. I goes to x, j goes to y. So 3 goes here and 5 goes here. Now that we have the columns all set up, we can now continue execution in the subroutine STI, which starts on line 4. Line 4 is returning x, is different from y. Well, let's see what is x is different from y. X is different from y is a condition. Okay, it gives you a true, false value. In this case, is it true or is it false? It is true. Okay, very good. So the right-hand side, or what the value that we are supposed to return, this is true. Okay, so how do we return a value of true? What do we do when we execute a return statement, regardless of what we are returning?
You just replace the question mark.
Replace the question mark with the value that you're returning. In this case, we just replace the question mark with true because the value that we are returning is just true. Okay. So now we are ready to move on to line 5. Line 5 is just bookkeeping stuff. Tells us we have to continue on line 9, and it is also time to deallocate those particular columns. So now when we get back to line 9, it will look like this. Okay. So that means true is true. Okay. When the condition of a while loop is true, what do? We go into the loop. So we go into line 10 in this case. Oops, keep using the wrong window. We go to line 10. Line 10 is evaluating the other condition, which is I is less than j. I is less than j is actually true in this case because I is 3, j is 5. After line 10 being true, we go to line 11. Line 11 is going to decrement j by 1. J goes from 5 back to 4. And then we get out of the conditional statement. We get to the end of the loop. When we get to the end of the loop, we have to go back to the beginning of the loop again to see whether we have to do it again. I keep doing the same thing. Okay. I'm checking whether there's a delay between the change of the focus and no, it's a user error. Okay, so we get back to line 9. Now, when we get back to line 9 this time, it looks like this again. Okay, because the value that we resolved last time is already used. So we have to invoke it again in order to determine whether we have to do it again or not. So we have to basically go through the same stuff again. In fact, if I want to be lazy, I can just copy and paste just about everything here, except I have to substitute the value of 3 to 4 because I spoke incorrectly. Because j is now decremented from 5 to 4, and when we use j to pass to y will also end up with a value of 4. But it doesn't change the fact that 3 is different from 4, so it still returns a value of true. And so when we get back to line 9, we still have true is true. Then we go into the loop one more time. Go to line 10. I is less than j is still true because 3 is less than 4. We decrement j again on line 11. It goes from 4 down to 3. Then we get to the end of the conditional statement. At the end of the loop, we go back to line 9 again at this point. And then we have to basically do the same thing again. This time it is going to return a value of false. Okay, so I'm just copy and pasting because we are running out of time. But this time y has a value of 3 because y is a copy of j, and j has a value of 3 at this point. But 3 is different from 3 is false. So we are returning a value of false, which means this part is changed to f for false. After line 5, when we get back onto line 9, then we have to say false is false. Okay? But when the condition of a loop is false, we get out of the conditional statement. So this is our ticket out of this loop onto line 16. When we get to line 16, we look up the return info cell. Oh, this is all gone, so we have to look up this return line number, which is post. And then we can now free up these 3 columns that we have allocated for the invocation of WRX. Okay. Are there any questions about this trace? This is probably one of the trickier ones in terms of concepts. But in terms of the amount of work, it's only 25 rows. Are there any questions about this one? This one illustrates the flexibility of a subroutine that returns a value. You can stick the invocation of a subroutine just about anywhere, as long as where you stick it is expecting a Boolean value. It's good. You can put it inside the condition of a conditional statement. You can put it inside the condition of a while loop. You can put it inside the assignment operation, as long as the left-hand side is also expecting a Boolean value. So that's all the time that we have today. There's no homework assignment over the break, so you guys have a good break, and I will grade the exam and also the homework assignment. So my break is going to be a little bit busier. It's my turn. Yes, I do.
How do I what?
Okay, so let me make sure I save this first. Close this.
Oh.
Yeah, if you need.
Left. It wouldn't have helped the situation at all.
Okay, so yours. Okay, I'll start with you.
W127
127
5524
5524, and you are Renee. Is it Renee or Renee? Renee.
Gonzalez, G-O-N-Z-A-L-E-Z.
Okay.
Yep.
All right.
My ID, 0453847. Tara, T-A-R-A, Schrader, S-C-H-R-A-D-E-R.
Okay. All right.
Oh, W, 1171
1171
042
042.
SY DAO.
Okay.
W1211 295. Eric, ERIC Severini, STV, ER.
Okay.
Is there anything I need to do? Or?
No. This one just is a reinstatement form. I have to finish the whole thing.
Okay.
Yeah.
We don't have to do anything with me, do we?
Sorry?
We don't have to do anything with me.
No. It's
I
nothing.
just want to remind you to upload the thing so I can study it this weekend.
Oh, okay. I can do the upload.